Hey guys.
Hi everyone, welcome to our Timefold Ask Me Anything session. Responsible for marketing at Timefold, and it's my pleasure to guide you through today's session. I'm joined with Geoffrey the Smet, creator of OptaPlanner, where it all started, and now continuing the project as the CTO and co-founder of Timefold. Alongside him, we have Lukáš Petrovický, our lead solver engineer, who plays a pivotal role to our at contributing to the core of our technology, namely the solver. Timefold is a planning optimization AI which enables software builders to tackle real-world, complex, and high-impact operational planning problems. It delivers significant economic value in optimization operations, and there's numerous use cases: extended VRP, maintenance scheduling, field service routing, task sequencing, you name it, typical planning problems and NP-hard problems get solved through Timefold. As you've heard, Timefold OptaPlanner, an open source solver created by Geoffrey, developed by him, Lukáš, and the rest of the team that also now continues their work at Timefold. We provide building blocks for building and deploying optimization solutions, as well as extensions and connectors to integrate with a variety of business applications. And lastly, our tools allow you to monitor, optimize, and analyze your implementation in a way you haven't seen before. Today, we'll be showing you some of the questions on screen that were submitted through the tally form that we've communicated. But of course, this is an Ask Me Anything for a reason, so please do interact in the live stream. We'll make sure we can answer those questions dynamically and have a real-time discussion on them. As you can see, this is our first public engagement as a team, and yes, something went wrong in the beginning of the stream, but that doesn't mean that doesn't change anything to the reason why we're here. We're here to dive deep into what Timefold is and what the vision is. So without further ado, let's start with one of the questions, and I actually have a question to kick this all off. Interesting to see your answers here. Which new feature in Timefold are you most proud of? Who's going to take that question?
I can start. Thank you, Ente. Hello, everyone on the stream. So, I was told to speak about one question I am most proud of, and I'm actually going to speak about two. First one of them is something that we're calling score analysis. I think it was first delivered in Solver 1.3, and there is a simple purpose behind the feature. So when the solver is improving its solutions, the only thing it cares about is the score of the solution. If it sees a bigger number, that means the solution is better, and therefore it's going to move on and continue using that solution going forward. Now, this is good enough for the computer, but this is not good enough for you as the user who wants to put that solution into their business and actually run their business with it. So what we worked on was on a way to make those solutions better understandable for you to really be able to drill down and look into what that solution really is. We are calling this feature that does that, score analysis, and you can see a sort of a mock-up UI of how we present information that is given to you by that feature. So you can see that for the particular solution, which ended up with a score of 0 hard, 0 medium, and minus 57,209 soft, we actually break down that solution for you per constraint. So you can see that there are a number of constraints in the first column, number of constraints, and you can see how many of each of those constraints were actually broken. So you can see that, for example, for the first one, for the constraint theme track room stability, the constraint is actually broken 18 times in your solution. And then there's a breakage of 10 times in terms of the popular talks, etc., etc. So this is how you can see what's actually going on in your solution. And if you want to drill down even deeper to the level of individual constraint matches, we can actually show you, that's what the last arrow on the left points to, that, for example, for the theme track conflict constraint, there are actually several constraint matches telling you, for example, that talk 4 and talk 2 are on the same theme, which is cloud, and they are happening at the same time. Which is telling you that in your conference, because it is from conference scheduling, in your conference, if people are interested in the cloud theme, they are going to have to choose from one of these two tasks, because they cannot be at the same time in both of those tasks. So it's a soft constraint, it's broken, and thanks to Timefold Solver, you can now see that this is part of your solution, and you can either accept that or not.
So it gives us insight in the result, right, of this Timefold Solver. Yeah.
Exactly.
And what was the second thing you really liked, which is new in the last few months?
Yeah, thank you. If you want to switch to the next slide. So some of you who are familiar with how you do, for example, vehicle routing with Timefold Solver have had to struggle with this sort of workaround for a while, where if you wanted some visits to be unassigned, to not count towards the current schedule, because you maybe want to do them tomorrow or the day after, you had to use something which we call a workaround called a dummy vehicle, where you assign all of those visits to a dummy vehicle, and then you exclude the dummy vehicle from the constraints. So the solver will still see all of those visits assigned to a vehicle, but the vehicle will not count towards the score. That's how you would make sure that none of those visits would actually be counted towards either hard or soft constraints. Even though it worked, it wasn't very nice to code. It introduced a lot of boilerplate. So we decided we are going to do something different. And from Timefold 1.8, which was actually released just a week ago, we now have something which we call the unassigned values in list variable. And now the visits you do not put in any of the vehicles are automatically treated as unassigned. So you could think that this is pretty much just an improvement on the API level, but it's actually not the case. And we were quite surprised to see it, at least I was, because when we started benchmarking this, we actually figured out that this is so much more efficient under the hood that some things that weren't possible before, some scales of problems that weren't possible before, are now very easily possible. For example, if you take a look at the last column, where it says huge on your screen, you can see that for the biggest of the biggest problems we see in our production runs, with the new feature, we are actually 3, 4, 5 times as fast as we were before. So finally, this feature, unlike the dummy vehicle, it finally scales to pretty much problems of any size, I would dare say. Yep. So these are the two things that I'm probably the most proud of. And if you want them, please upgrade.
Yeah. I'm really excited about this last one too, right? It's less boilerplate code, and in any vehicle routing problem you come out there, it's always there's more work to be done than vehicles you have available. So this is really big upgrades, right? So if you're using vehicle routing, please take a look at Timefold 1.8. To answer your question too, sir.
We actually have a follow-up question, which I'll see if I can put it on screen. Mm-hmm. So this question is basically, how is what you're explaining, Lukáš, different than a variable that hasn't been initialized?
That's a very good question. So in terms of list variables, there actually never was a concept of uninitialized list variable. Everything that was a list variable was always initialized, and you always had to assign things. So all of your visits always had to be part of some vehicles list. So that's what we're changing now, and it works similar to how unassigned variables, previously called nullable variables, work with the basic variables, because there we actually had the functionality for years now. This is only new to the list variable, where this concept previously didn't exist at all.
Okay, and then there's also a question about actually community building, or how we cater to our community. Have we considered creating a Discord for building the Timefold community?
Good question. We have some talks on creating a chat channel, and this could be Discord, this could be Slack, this could be Zulip, of course. And I think we should continue those talks and actually get one rolling. And Discord would be one of the potential good options, I think.
We are very present on Stack Overflow, on GitHub discussions, and we try to answer in a very timely manner. Well, when I say we, it's actually mainly Lukáš, I see, who's very carefully taking up that task. I believe with a Discord or with a Slack or alternatives, there's also like that real-time element that is expected, and that's something we really wish to cater for, but that at this time is also hard to pull off. But it's definitely something that's on top of mind for us.
Definitely. So
and then the questions keep coming in. So let's go over this one before we go to the other questions that were submitted. Do we plan to launch a web portal to generate the planning entities and constraints out of the box?
Short answer, yes. So if you look at our quick starts right now, you will see we have many use cases there, and we're adding more use cases. We're bringing over use cases from the examples. And what we want to do is we want you to be able to easily say, okay, which use case do you want? Which constraints do you want from there? And you pick and choose the ones you need, and all of the others aren't there. So the example becomes much more readable and just does what you need it to do, right? So we're definitely working on that.
Okay, thanks for those contributions. Keep them coming if you have any other questions, side questions, etc. And we'll now continue with one of the questions that was submitted through the form. And it's actually a very exciting one and a question that comes back a lot. When will you release the Python solver?
So the short answer for that is this spring. So we're working on that. Just to give you an idea what's been happening there. This is a first implementation, as you can see, which we're working on. But here we, for example, have a lesson class, and we have a planning variable of assigning the time slot. And then if you scroll down, you would see the room there. But you can still see we have some improvements to make. Like, for example, here we still define the value range, while you don't have to do that anymore in the latest versions. So we're improving this example. We're looking at data classes in Python to make sure this amount of code really reduces to the bare minimum you would need to solve these use cases. So stay tuned. It's definitely coming soon. And when we do, we're going to add it to the quick starts, where you expect that, where we already have the Java and the Kotlin examples. And of course, you will then have the Python examples there. And we will also add it to our documentation. You can see we've already have our tabs for Java and Kotlin. So we will be adding a Python tab soon.
Thanks. And we're continuing also with a forward-looking question that came in. It's a very broad one, and I think we can elaborate for a long time. But I'm curious to see how we answer this one. What's the roadmap of our solver?
Right. So this is one of the questions I think it was asked through the forum. So we have a slide prepared for it. First of all, as you've already seen, we are working on the Python solver. That's a major piece of work. So that's going to take a while. We are going to be working on load balancing and fairness in constraints. So in your constraint providers, it's going to be easier to do those things more naturally than perhaps it would be now. And then we have two features that are actually very big and that are currently on the drawing board. First of all, we through our work on some of our own internal models and through our work on Stack Overflow and on GitHub discussions, we have seen that writing variable listeners currently with the solver is a major pain. We want to make that pain, if not non-existent, then much smaller. We want to make them, first of all, more testable. We want to make them more declarative. Ideally, we also want to make them type safe. Let's see again, as I said, this is on the drawing board pretty much. And then the next thing we do see as absolutely necessary is better support for custom moves, because that, I think, is currently the main limiting factor in terms of what you can do with the solver. If your moves are for your particular custom problem, if your moves are not good enough, then the solver is not going to be good enough. Unfortunately, writing custom moves currently is a lot of boilerplate. It's a lot of there is a lot of things you need to know to be able to write the move correctly, and we essentially want to eliminate that. Much like we have turned writing constraints from maybe incremental Java score calculator to constraint streams, and we made it much more simpler in that process. We want to do something very similar to how you implement moves with the solver. So those, I think, would be the 4 biggest things we have on our mind. For some, like for the Python solver, we already know it's a matter of a few months. It's going to be this spring, as Geoffrey said. For the other ones, maybe a few months, maybe longer. We are working on it, and those are the things we absolutely want to get done.
Yeah, and those are the very, very big things, right? We have 100 small issues being solved every day or every week or every month, as you guys can follow this on our GitHub. But these are the ones where this will take months to implement, right? So for, one thing I really like about this one is the fairness one. I would just like to dive into that one a little bit. So we already have an example, the 10x example, where we do a little bit of fairness, where you just say, okay, we want to, for example, make sure that every team and every tennis team plays the same amount of matches. And what we do in there, we do this constraint that says we want to look at the time assignments, we want to group them per team, and then we want to do load balance across that across all teams. But this involves custom code. And for example, this load balance code does not exist yet in Timefold itself. It only exists in the example. And so we want to make this a lot simpler to use and a lot more standardized and a higher quality, right? So this is one of the things you'll see relatively sooner, because it's a relatively small issue. But the other things like the variable listener changes and the custom move changes are a big long-term investment with heavy designs to make it as simple and as easy to use for you to use. But that won't be delivered in a day, of course. That will take time to build. So what's the next question, Jente? You're muted, Jente.
I was muted. We actually have some questions coming in also on the YouTube live. And for Naveen, I basically want to say that we're shoot us an email, go to our website, timefold.ai, contact us there, and we'll definitely answer you within the day's notice on how Timefold can help you with your scheduling solution. And then there's a question from Cody, and he's asking us if we offer consulting, either hourly or project-based.
Yeah, so first and foremost, we only do consulting when a support subscription is involved from our side, but we do have, and so contact our sales if you want more information around that. Just fill in our contact form on timefold.ai. And also our partners can also help if we don't have the manpower on our side, right? But we do have a number of people available here to help with consulting.
Okay, and then over to one of the pre-filled questions, and that's also an interesting one. How does Timefold cope with vehicle routing for which the road network is the work? For example, the examples that were given in this question were snow removal, gritting, vegetation cutting, road cleaning, etc. I think this refers to arc routing.
Yes, indeed. So just an intro for people just to show the difference, right? So in a normal vehicle routing problem, we send a number of vehicles across the country to do delivery at certain locations, or to perform a service there, or to pick up at certain locations. And of course, you have all of the constraints in there, like in this case, capacity or skill constraints or time windows. in this problem, you might have some of these constraints too. And of course, you want to minimize the travel time, but it's more complex. You have a road network like this. And for example, you need to remove all of the snow, but another one, in some countries, the trash gets collected at the door, for example, which is the case here in Belgium. And so you want to find the shortest distance to travel through all of these streets to collect the trash. Or to, for example, the mailman to deliver the mail, right? Vegetation cutting and so forth is other examples of that, like you just said. Now, the first trick to know when you want to solve this problem, when you want to model this problem, is you can start from our vehicle routing example, but you have to make some changes. And the first thing you really need to understand quite well, that there's a difference between a street and a street segment. A street is, for example, this is let's say the school street, right, which is certain amount of length with a certain amount of corners and a certain amount of people living there. And you don't really care about the specific houses on that street. What you care about are what we call street segments. That's basically going from corner to corner with no corners in between. Those are the street segments. And what you want to do is you want to plan the street segments, not the streets. You want to say which street segments you do first, which you do second, which you do third. Now, ideally, when you do one street segment and you go to the next, those two are connected to each other. So, for example, you might do this street segment and then this street segment going to here horizontally, right? But it could be the case that they're not connected. For example, when you do this dead-end street, when you get to the end, you will have to drive some time where you're not really, doing the job, such as whatever you have to do there, right? So in that case, so you basically create a list of street segments, and when two street segments don't connect to each other, when they're next to each other, you take the travel time going from one to the other, right? So how do you do this? Well, if you look at our quick start example, right? You look at our vehicle routing quick start example, which does a lot of things already. What you will see in there, we have a vehicle which has a list of visits, and each vehicle has a home location and departure time. That doesn't change. That's the same thing, right? And then you have your visits. Well, and your visits here have a single location, which is different for when you're doing a street segment assigning, arc routing, right? And they have a service duration. The service duration, again, is the same depending on how many houses in the street or how many snow in the street or whatever the case may be. You set a certain time to clean that street. And then, of course, you have a certain arrival time at the street. Now, the thing we're going to change here is we're going to split up this location into two locations, a start and an end location. It gets a little bit more complex when you can go through a street segment from any kind. You can go it from left to right or right to left. But let's presume for now the simple case where you, for example, are delivering mail and you have to travel one side of the street, and then there's another assignment, another one to travel the other side of the street, right? Then you have a start location and an end location. And so you just assign those visits in order. And when you see when one visit to the next has where the end location of the previous visit is different from the start location of the next visit, you add in the travel time, just as we've always done in the vehicle routing case, right? So just like in the vehicle routing quick start. Of course, this isn't too pretty. If you want to really make this pretty, we of course rename the visit into street segment like it is here. And then you have a good base to start from. It gets a little bit more complex, like I said, when you want to add asynchronous async, where you can travel the street in both directions and things like that. But this is the base principle, basically.
Okay, and then we have a lot of exciting questions coming in, so keep them coming. Can you please explain the new allow unassigned value feature a bit more? Are the unassigned customers still added to some of the vehicles lists of customers?
No. Yes, we can. No, they are. Previously, all of the unassigned customers would be assigned to the dummy vehicle. That is something you had to do. You had to do yourself. You had to introduce the dummy vehicle and then make sure in your constraints that the dummy vehicle is actually excluded. Now with the unassigned values, those customers are not going to be assigned to any lists. So their inverse shadow variables, they're actually going to be null. And you can specifically ask in your constraints using for each including unassigned values that you are also interested in seeing those. Otherwise, you are not going to see that. So effectively, we have taken the boilerplate you previously had to do with the dummy vehicle to get this done, and it happens automatically without you dealing with that. But if you want to have sort of the same approach of still finding all of the unassigned customers, you can do that just by using a different variant of for each, exactly as it works with the basic variable, which was previously called nullable. Now it's also called including unassigned.
Thanks for that question. Geoffrey, you are on mute. So
yeah, and just to illustrate how that works is you basically just say, this is the example I've showed earlier around vehicle routing. What you just do is on the planning list variable, you add an allows an assigned true, right? And then of course you have to add the medium constraint to make sure that some of the visits still get assigned. Otherwise it will prefer not to assign any visits to minimize the travel time, right?
But definitely thanks to us that if this all goes a bit too quickly, definitely we'll put the recording live on YouTube as well, and feel free to definitely ask more questions on Stack Overflow, GitHub discussions, or reach out to us directly on timefold.ai.
Yes.
I have
for this sort,
I have a question coming in that I really go ahead.
Please go ahead.
I have a question coming in that I'm really excited about because for me, being part of the team, this is the question that I also like to see. The person, Chris, hi Chris, he's considering Timefold for a capacitated VRP with the time windows problem. It has 1.1K vehicles and 17K stops. Is this within the realm of Timefold?
So
Yes.
Yeah, most definitely. Now you do have to take into account a number of challenges, right? So for example, if you need a road distance, right? 70,000 stops, presuming they're all 7,000 unique locations. That means you need a distance matrix or a travel time matrix of 17,000 squared. And that will run you up to about 8 gigabytes of RAM just to keep that in memory in its most efficient form, right? So what I often see is people with Timefold, we can go quite far, but what I often see people limit to around 5,000 to 10,000 stops in a single data set. But if you have the memory, there's no reason not to do this. The second thing you need to know is you want to be using nearby selection for this one. So if you take a look at nearby selection in the docs, you'll see that once you have this many stops, the quality of your solution will increase a lot if you use that. Nearby selection has no effect. If you only have 200 visits, then there's no point in using it. But you have more than 1,000, more than 10,000 visits, you definitely want 10,000 stops. You definitely want to use that.
Yes, and just on my end, we actually have a quick start for capacitated vehicle routing with time windows. So that's what you can use to sort of get you started. But especially if you need nearby selection, I think you should come talk to us.
Okay, thanks for that. Continuing with one of the pre-filled questions in the tally form, how do we debug, or how can one debug the score and variable listener corruption?
So do you want to take this one, Lucas?
Okay. So how much time do we have? So this is one of the more complex, probably most complex things you may want to do in the solver. And it comes from the fact that, first of all, variable listeners are very hard to test, which we already explained. We want to do something about that. And from it also can come. It can also be coming from your constraint streams, from your constraint implementations. There can be two reasons for that. First reason is you may have done something wrong. For example, like transitive dependencies from one entity to another without using a join. That would be a problem that would result in a score corruption. or in rare cases, it could be a bug in the solver implementation itself. So what you're gonna have to do, or rather what I start with when I'm doing this, is I enable full assert environment mode to make sure that the solver immediately fails when it sees a score corruption. But then it's actually the second job is sort of to minimize the problem so that I can pinpoint precisely what's causing it. So what I do is I remove all of the constraints except for the one that is usually causing the problem. So you start removing constraints one after another until you find out what's the one constraint that's still your problem. What I also do is I go through the data set and I start removing entities. Typically, I get down to like 2 or 3 entities, which when switched in particular order, typically introduce a corruption. Barely ever is it more like 4 or 5 entities. It doesn't really happen. It's usually 2 or 3 entities. And the last thing you want to do is you want to remove as many moves as you possibly can. So if you're using a change move and a swap move, then perhaps remove the swap move because you will also reproduce it with the change move only. Or vice versa. Or maybe remove the change move because the swap move is going to be enough. The point is, remove as many variables from the problem as it's possible. And from there, you can actually start debugging the problem. So you can add, for example, debugging outputs to your source code to see all the state transitions in your entities, in your variables. You can use debugger to do that, debugger in your IDE, to do that in a more sort of sophisticated way.
One thing I do have to notice that we've seen less and less of these, because one of the things we've done is by creating more models in the quick starts, you get a better model to start from. So the last chance is lower that you do something really strange that would create one of these problems. With variable corruption specifically, we have a new feature, I think 1 or 2 releases ago, which does help. But when you run into it, it gives you more information what actually happened, which helps to more easily find out what's wrong in your code, right?
Yes.
So definitely try the latest version of Timefold when you run into any of these, and try play with the full assert mode to really get more information what's really going wrong and what could be the cause of it. Right?
Yes. The point I was trying to make was that there are multiple reasons why you're getting a score corruption. There are various ways how you could find what the score corruption is if you already know where it's coming from. And this is probably the hardest problem you will ever have to deal with when you're using the solver. Thankfully, they are not at all frequent. And once you get it right, you are likely never going to get it wrong again. But yes, these are hard to debug, very hard to debug. And as I already said, we have some solutions in mind, but they're going to take a while to develop.
Okay, moving on to the next question. It's about horizontal scaling with Timefold and putting it in a cloud native app.
Yeah. So just to share my screen around this one, this was also a pre-submitted question. So one of the things we've done is we've taken each one of the quick starts, the maintenance scheduling, the vehicle routing, the employee scheduling, and so forth, and we've actually made them into a REST architecture. So what does that mean? In the past, we pushed them into a database, then got them out, and so forth. Now we've standardized all of the examples to work like this. That basically, the browser sends in a JSON with the problem, the input problem. We solve that and we send that back through REST to the browser. This approach means that you can easily replace the browser here with, for example, your middleware that connects to your database or databases, that connects to your event stores, or potentially also your own UI, right? And we see that this is a much better way to put Timefold typically into an existing architecture, right? This is the typical microservices architecture approach, right? Now, You don't get scaling with this yet. What you get with this is the a standard rest in and rest out, right? And that's what all of the quick starts have. Now, one of the things what you really want to do is when you want to do horizontal scaling and you want to put it in a cloud native app, is you want to be able to scale horizontally. That means that when a lot of data sets come in, right? Let's say for 100 data sets for vehicle routing, that you can solve those and that you can spread those across multiple machines. And that you don't have to have 100 in a queue where you're solving maybe 1 or 4 at the same time, and it takes a long time before the last ones are actually solved. The other thing you want to do is you want to scale to 0. You want to make sure that you only use the cloud hardware that you need at the time that you need it, and the moment you don't need it anymore, it comes back, it scales to 0. So one of the things we're developing for that is basically an orchestration platform, and it will deliver a number of other things on top of that. And it's based upon Kubernetes. You don't have to use this, of course. This is not part of the open source or the community version, though, for the record. But we're building a platform that allows you to say, okay, I have a Timefold problem. I have an implementation. For example, you take any of the quick starts, right? You've built this with the community version. You say, okay, I now want to deploy this and scale this on Kubernetes. Then you might be looking at this offering. And so what it is basically your planning problem comes in, you solve it, and it gets sent to one of the Timefold Solver pods, right? And as we need more, as more data sets come in, as more problems come in, we automatically scale up to more pods, and as they are being used, they automatically scale down to 0 pods, 0 Timefold Solver pods, of course, right? And this is basically, now that being said, in community, in the quick starts, you will see that every one of them has the ability to build a Docker image. So if you don't want to go down this road yet, you just want to have a simple Docker image, simple cloud native app, you can just build a Docker image there too.
Thank you. We're actually nearing the last 2 pre-filled questions. So if anyone also has some live questions, definitely feel free and go ahead. So the second to last question, how can I trust the solution returned by Timefold?
Yes, that's a good question. So there are 3 things that come to mind. First of all, if you're writing your constraints with constraint streams, we have something that's called constraint verifier. And it works similarly like assertions in JUnit or SRJ, where you can actually write your constraint, you can have it tested, and you can say, okay, this constraint is supposed to penalize by 5, or it's supposed to reward by 3, and we make sure that actually happens, or that you get an assertion failure instead. So first thing, you need to make sure that your constraints are implemented correctly, and you can do that by testing your constraints using constraint verifier. Then the second thing you already seen is once you get a solution from the solver and you are not sure if you can trust it, go into the solution, ask for score analysis, and the solver will tell you exactly what's in that solution. And you can then check it manually if you like to, if that actually matches what's in there in the solution that was provided by the solver. Spoiler, yes, it does. And the third way was also already mentioned. When you're developing your application, so not in production, you may want to use something that we call environment modes, be it either fast assert or full assert, that is going to fail the solver immediately when it runs into a critical problem. For example, like a score corruption. So when you are developing your solution, not in production, please enable those and see if the solver is doing what it's supposed to be doing. If it's not, it's going to throw an exception. The reason why I'm saying you shouldn't do this in production is because these modes, and especially the full assert mode, are very slow, because they have to check so many things that are happening in the background. So full assert mode is probably going to run 100 times slower than the normal reproducible mode you would put into production.
Yeah.
So that's why I'm saying use those modes, but please only use them for development.
And just for context, we have tests running, CI tests running, which enable those full assert modes for all of our quick starts, for all our examples and so forth. And they rarely do or never fail, right? It's really our way to make sure that the solver behaves correctly, that the quick starts behave correctly. But if you write something new, it's definitely worth enabling that locally for once in a while and seeing how that works out, or even create a unit test around it.
Yes.
I'm a very big fan of the testing the unit tests, testing your constraints, right? That's been just the ability that you write a constraint, but you can also verify that it does what you expect it to do is worth its weight in gold. And this is something we did not have in the past, but we had with like the score DRL, which was very hard to do back then. But now we have this, and the big advantage of it is it's isolated. You can test one constraint in isolation, so that means when you change any of the other constraints, that unit test doesn't break, nor does any of the other unit tests, except potentially the one of the constraints you changed, right?
And then we have a question coming in also from YouTube. How do we deal with traffic data in the nearby selector? Definitely in the case where the travel time between two locations happens to vary throughout the day.
That's a very good question. So first of all, traffic data is hard. Let me first explain why traffic data is hard. It's because the amount of data you need to set up a travel time matrix. So normal travel time matrix, you have to know from every location what the time is to every other location. So presume you have 100 locations, then you have 100 squared or 10,000 cells in there. Now, if you then say I have a travel granularity of 15 minutes per day, let's presume you're only solving it for 1 day. We have cases where we sometimes solve it for 3 months, but let's just say you're solving it for 1 day, and you take a 15-minute granularity in there. That's almost 100 different, 15 minutes across a day, actually 96 to be correct, right? 24 times 4. Now, so almost 100. So that means that when you have a distance matrix of 100 locations times 100 for, because it's two-dimensional, times 100 for the time granularity, right? That becomes already 1 million, right? And so the travel matrix or the distance matrix really grows very heavily once you start introducing travel data. Now, when you actually look at the nearby meter, right, you will see that the only thing it needs to know is, given from one location to another location, what is the travel time. Give me back a measurement of how long it takes. Now, one of the things you can do in there is you can take in the average travel time with traffic in there. So you could say if normally it takes an hour, but certain parts of the day it takes 2 hours, you can average that, and you could return that number. Just know that the nearby meter is a probability thing. So it doesn't need to be correct. It will just help to focus more on locations that are relatively closer to the ones you want to connect to than the ones that are farther away. In fact, if you just simply do not count traffic whatsoever in your nearby distance matrix, I would expect it to work quite well, because even though traffic changes throughout the day, and in some locations it goes up much faster than other locations, so it does distort the field a little bit. It typically won't have. It will have some effects on like what is the 40th nearest distances for nearby selection, but it won't have an effect that everything that they completely change, right? Maybe the ones that are nearer to the city will not be the nearest anymore. So in most cases, I would not take it along traffic data for the nearby calculation. I would take it along, of course, for the actual calculations of the arrival times and to make sure that you have enough time to deliver to visit all of your visits in vehicle routing. I hope that answered the questions. That answered the question.
Then, if there are no more live questions coming in, we just reached our last question. It's a Good. Last question from my end, actually. What's the best way to start with Timefold?
Yeah. So what I recommend everybody, if you want to start with Timefold, is you just go to our website, right? You go to Get Started or Documentation, and so you can start with any of our Hello World examples, Hello World explanations here. But personally, I really love going to the quick starts, because if you go to the quick starts, you will find a whole bunch of quick start examples here, like the vehicle routing example, the maintenance example, the employee scheduling. So while in docs, we will explain you what an entity is, what a planning entity is, what a planning variable is, and so forth. And it's definitely worth going through those. You will often see that whatever case you have, look for the quick start that is closest to the problem you have. If you have a vehicle routing problem, take this one. If you have a maintenance scheduling, take this one. Employee scheduling, take this one. And for each of those, you can just go through, you can click through to the actual README. You can clone this repository. And with these two commands, you can clone the repository and then run it and immediately locally see it running, play with it, maybe change the JSON data you send to it, and then start playing with the constraints and adding your constraints and adding your whatever business complexity you need to it. And of course, all of these examples are done correctly. They all have unit tests in there. So for example, here's the vehicle routing unit tests for each and every single one of the constraints, right? So these are high quality quick starts.
Thank you. And then there's more questions pouring in through the chat. How do we optimize for pickup delivery, so last mile delivery VRP, as it is taking more time?
So there's a difference between doing only pickup or only delivery, which is a normal VRP problem where you can start from our quick start, and when you want to do both pickup and delivery. And then there's a difference in that case with pickup and delivery, whether or not you pick up something and the next visit immediately drops it off, in which case you can do it very similar to the arc routing example we showed earlier, or where in the case where you pick up something else, you drop off the second thing, you pick up a third thing, you drop off the first thing, where you basically have mixed pickups and deliveries. In that case, you cannot really use the model we have there for vehicle routing. You want to use a more advanced model. We don't have a full example of that yet, but what you want to use is a model where you have the pickup and the delivery as a separate visit, and you add a custom move to make sure that when you move the pickup from one vehicle to another, that you also move the delivery to that other vehicle, right? Pickup and delivery next visit. I'm not quite sure which of the case that.
Yeah, so Praveen is basically saying, like, in his case, he would pick up now and probably deliver on the next visit.
Oh, well, in that case, well, the thing I showed earlier, right? So let me bring that up on screen again. Just a second. It's basically the exact same thing as the arc routing thing. So remember, if we went to the arc routing, so what you see here is we have a vehicle that does a number of visits. Well, what I would say is this is the visit, this is the pickup location, and this is the delivery location, right? And it takes an amount of time, of course, to drive from the pickup to the delivery location, but you basically string together these pickup and deliveries as a single visit, right? You just say, pick something up, drop it off. So this is basically the taxi problem. You pick up a person, you drop them off, you drive to pick up the next person, you pick that person up, you drop him or her off. And so the interesting thing about this is that when you look at the travel time, there's two types of travel times: the empty travel time, which is between the visits, and then the transporting travel time, which is in the visit itself, right? And of course, you have to sum these both up to make sure that the driver is not working more than 8 hours or 9 hours a day, and all of the other constraints you typically have in a vehicle routing problem. You're muted, Jente.
Then it looks like we're ending again where it started. So questions about our Timefold Python solver. Mm-hmm. It's basically performance related. Will it have the same or close performance as the Java solver?
So, right. Claude, you want...
So we are going to great lengths to make sure that the performance of the Python solver is close to the Java solver. We are not yet sure how close we're going to get. I think the current numbers are somehow around 60% of the Java solver performance, something like that. But again, this is work in progress, so we do not yet know where we're going to get with that. But definitely the aim is to be very close to the performance of the Java solver, as close as we possibly can. And the way how we actually want to get that done is we are actually going to be running Java. So it's going to be Java with some talking to Python, where your code will be Python, but we are actually going to be running it in Java. So that's how we currently think it's going to be. It's going to be very close to the Java performance. How close? We are about to find out.
Yeah. So and we've done a whole bunch of improvements there. Just some history on this. A long time ago, this was still in the Optoplanner era. We had it was 20 times slower, right? And so now we're at 60% or so around of the Java solver. Now, like any other library in Python, when you, for example, look at the TensorFlows and so forth, you'll see that you use them fully from Python. You do not notice there's anything else underneath, but often there's another language underneath. And it's the same for us. Every single line you write will look and feel like Python, right? The full example will be fully written in Python. We will have a vehicle routing example. We have a maintenance scheduling example fully written in Python. But under the hood, we make use of all kinds of performance tricks that it all fits together quite nicely. Right?
And I think that just concluded the last question, and it seems that we're able to wrap this up in under an hour. So I'm thanking everyone that attended, asked questions, submitted questions, and also you, Geoffrey and Lukáš. I think this was very insightful as our first Ask Me Anything. And see you next time.
Thank you. See you next time.
Thank you, everyone.
Bye.
Bye.